This week on the show, we're going to cover what's new in OpenBSD's latest release. We're going to show you a little bit about the paper evolution of Unix Time Sharing system and tell you the story of how Ping got developed, along with a great interview of BSD Now alum Kris Moore about the new FreeNAS release. So you might want to stick around for your weekly show about BSD Now. BSD Now, episode 190, The More You Know. Recorded on April 19, 2017. Hi, I'm your co-host, Benedikt Reuschling.
And I'm Alan Jude.
And we have a great show prepared for you today, so we should get right into the news section here. The first item is OpenBSD 6.1 was released. And of course, on time, as promised. And this is their 42nd release. And they have a big list of changes there. So we should only list a couple of them because that might go over a little bit longer. But what's the news?
So the biggest thing is they have support for some new platforms, including ARM64, which brings in the Raspberry Pi 3. And we'll have more about that in another story later in the show. But the big thing that changed is that brings in Clang as a base system compiler. Because
so they're doing the change as well.
The version of GCC they have can't work for ARM64, right? Because the last open source version of or the last GPL v2 version of GCC was long before anybody thought there would be a 64-bit ARM platform.
Yeah, so it's a good way to get into the newer platforms with changing the base system compiler.
Yeah, so they've not switched to it for everything yet, but ARM64 is built with Clang. They also added the new Longsoon platform. They've now support the 3A CPU and some of the other chipsets, but they have retired a couple of platforms, including ARM-ish, Spark. They're getting rid of Spark, and Zarus. Those are all gone now. But other big things, they have lots of new stuff happening in VMM and VMD, their hypervisor.
Okay, that's good to hear.
Lots of improvements to the wireless stack, lots of generic improvements to the networking stack as they move towards unlocking that. They've made a lot of changes to the installer, including giving it the ability to install over HTTPS instead of only FTP. They have routing daemons and other user network improvements that have gone through, lots of security improvements. They've
of course
made large enhancements to their custom DHCP client, DHCP server, and relay server client. Lots of other improvements, plus updates. Open SMTBD is now version 6. OpenSSH is 7.4. LibreSSL is now 2.5.3, and they have a new version of Mandoc as well.
Okay, so that's also for people taking part of that upstream development, might also want to update those components as well.
Yep. Support for other platforms like Pine64, Raspberry Pi 3, and the new Optron A1100. Lots more SMP improvements coming up, especially in the networking stack. They have their new display manager, XenoDM, which is based on their fork of X, Xenokara. So lots of interesting stuff there. Cool. Also updates to the package system tools as well as the package collection itself with an increased number of pre-built packages for more popular and faster architectures.
Yeah, that sounds good. So all in all, a release people should check out and see whether their favorite bug is fixed or some new features were added. Yeah, so if you are on the OpenBSD train, then check out that new release.
Yep.
Or if you already have that one, report how you liked it and, send feedback.
Yep. So our next story is from Norway. It's actually how to do fuzz testing on OpenSSH.
Oh, with the AFL?
Yeah, with the American Fuzzy Lop. weird name for a program, but it is. So
yeah, I used it in one of my labs, but in a much easier context, so that students get to know about the program. But this one is used on OpenSSH.
So the Garden Nosum wrote a blog post about how to use AFL to fuzz OpenSSH. So the first part is actually about how to compile AFL and OpenSSH with some special LLVM options to get extra instrumentation into the program, so that you don't have to do the way AFL normally does, which is patch a bunch of the assembled code with awk. But it also allows us to take advantage of other features, like LLVM has this option of a deferred fork server model, where you can... it makes it faster for repeatedly testing, booting up the program, and so on.
Yeah, right. It has to run a couple of iterations to, change the inputs that it's providing to the program.
So they
testing.
When they compile OpenSSH, they disable a lot of the stuff they can at compile time, removing support for sandboxing, not compiling as a position-independent executable, so that the addresses aren't randomized and so on. And some other features are disabled to increase the debuggability and so on, and try to make breaking SSH easier as part of the process.
Yeah, because it's relatively, of course, it's secure by default, so they had to make it a little bit insecure to make AFL run on it.
And part of it's just to increase the chances of finding stuff, because it's mitigated by the mitigation doesn't mean we don't want to fix the actual bug. But also, as we'll see, one of the other ones, they actually had to make a one-line change to the code, although it was a config option you could change before. It isn't anymore. They wanted to disable the privilege separation, because that happens basically when you connect, SSH starts a fresh copy running as an unprivileged user and runs all your stuff there. The problem is when AFL does make that crash, the SSHD that AFL is running in isn't what crashes. It's the client, the privsep child. And the regular one then exits normally rather than with the seg fault, and AFL doesn't detect that it found a problem. They disable that. Used to be a config option, but that config option was removed because why would you ever want to disable privilege separation? So there's a one-line code change to make it not do the privilege separation so that you can do it this way. Basically, it runs SSH in debugging mode with the inetd options, so that basically you can drop the input to the standard input of SSHD, and it'll do one connection, then it'll exit. And it makes it much more sense for, say, all right, AFL, dump your fuzz data into SSH and see if it crashes. And it can just do that repeatedly. Whereas if you actually ran it as a server, it would be a bit more complicated.
Yeah. Okay, so that's how they prepared the actual tests.
Yeah, so then they had to make a number of other changes to make it easier and faster to do the actual testing. So they made a number of other changes. All the patches are up in a GitHub repo they have for it. But if you want to understand what they changed, you see that they modified the arc4 random, the local version that's built into SSH, to make it actually not call that, but to just memset the buffer to 0. The idea here is that by not coming up with a random token for each session, it allows you to do a replay attack. Basically, you can come up with the message you're going to send to SSHD once and repeat it many times, whereas normally they're randomized and you'd have to encrypt it with a different key each time to prevent someone who's listening on the wire from capturing you logging into SSH encrypted and just sending those encrypted packets again. They're different for each connection, and that means that you can't send the same input twice and get the right output. But
so
in the case of fuzzing, that's what you want to do. So they break it on purpose. And then they do other tests. First, they disable the checksum check by just adding a 0 to the if. The idea here is, just because it doesn't pass the checksum doesn't mean we don't want to run the code that's normally guarded by that. This way, we don't have to send the right checksums. Then it also disables the MAC so that we're going to, run through everything but not verify that it wasn't modified, so that we can, try to trick SSH into working on evil data instead of good data, so that we can find where it would crash in that case.
If there's something malformed, and then
to make things easier when customizing stuff, they added the none encryption back as an option, so that for the SSH2 protocol you can connect with no encryption. Again, that's so that you can just feed this data in and randomize it better. And then to make it fast, they add the call to the AFL init to do the deferred fork server mode. And it kind of describes what that is in a bit more detail. And then they had to add in some stuff to make it, when it does fork, not close certain file descriptors, so that you can still feed it stuff from AFL. And then they disabled the Diffie-Hellman key exchange and the curve, elliptic curve stuff. Just if def zeros some of that stuff out so that it doesn't spend all of its time doing that, so that you can do more tests in the same amount of time. He says, with this patch in place, the execs per second went up to about 2,000 execs of SSHD per core. So it means you can cover a lot more fuzzing than you could when it took a lot longer.
Yeah,
and you got fewer
you don't have to wait for a long time to get some results.
So then they talk about how to actually create the test cases, but also mention a bunch of things they didn't try, like what happens if you run SSH in agent forwarding mode, or enable arbitrary port forwarding, or do the X11 forwarding, or use SCP to try to transfer a file, or use a password instead of a public key, and so on. So all those things are things they didn't test yet. So if you're interested, you can grab the code off GitHub and write some test cases for those and run them through this and see if you can't find any bugs in SSH. So they walk through how they created the dictionary of different values that AFL might try to mix and use together. And then they actually show how they actually ran it and what the output looks like, and all that. They found a couple of crashes. Null pointer dereferences during the key exchange. Fortunately, these aren't really harmful in practice, because you'll crash the privsep binary that forked off for that one connection. So all you're going to do is close the connection you were trying to connect to, and not get anywhere. And it's not going to do a denial of service and stop anybody else from still connecting to SSH. But why not fix it? So it was reported, and it's they have a link to where it was fixed in OpenSSH.
Okay, great.
But yeah, it says, apart from two harmless null pointer references, wasn't able to find anything else in the 1 day of testing they did. But he says, I hope some of these techniques and patches I used here will help more people get into trying to actually fuzz test OpenSSH.
Okay. So that sounds good for OpenSSH with all their security built in.
Yep. But yeah, on top of this, it just kind of gives somebody an idea of what type of things to try to tweak. So if you want to test SSH, especially in, say, if you have a slightly different use case than a lot of other people, or are using a newer feature or an older or less used feature, you might want to work it out better through the AFL. But the other option is some other daemon that you use. You can kind of look at the technique they used here and see where you might make changes and how to compile that other daemon in order to do similar testing.
Yeah, that's a good idea. So you can extract a lot of information from that blog post and run AFL yourself with these instructions.
Yep. So, as promised, our other story is about getting OpenBSD running on the Raspberry Pi 3.
Oh, okay.
So, Ian Darwin writes up on the Undeadly, the OpenBSD journal, about his work on deploying the ARM64 platform and Raspberry Pi 3. So he has, as you can see on the screen here, this empty white birdhouse-looking thing out in his yard. And he would like to use it to build a remote temperature sensor and weather station for his house.
That's a perfect use case for the little Raspberry.
This is, for the last while, he's had a little weather station, but it's been mounted on a dark-colored wall of his house, so that's not as good. But when he put the sensors in the birdhouse, the signal was too weak to reach back to his reporting equipment in the house. And he says, currently he can't move the birdhouse because it's very concreted into the ground.
Okay, so
his next plan was to build an OpenBSD computer, use the temperature sensor stuff, and then stream the data back to his house over Wi-Fi, which would be stronger than the signal the weather station uses. So he says the Raspberry Pi computer are interesting in this way because, they're a low-cost computer for everyone, and they take some shortcuts to save money, like not having a BIOS and, other types of firmware and so on. So he kind of walks through a little bit about that, but he says, there's... So before you read on, note that as of April 1st, 2017, this platform boots up, but is not ready for prime time. But it's definitely closer now. It's a couple weeks later. But it doesn't have the SD card support yet, but you can use the USB disk. And it doesn't have support for the built-in Wi-Fi because it's Broadcom, but you can use the wired Ethernet or a little USB Wi-Fi. And he says the HDMI driver isn't used by the kernel, but you have serial, so you're not going to use an HDMI driver out in the birdhouse anyway. And he says that the OpenBSD port tree isn't ready to cope with the base compiler being Clang instead of GCC.
Right,
OpenBSD is still working on that. But he basically walks through how he built his little birdhouse weather station. And some of the adventures he had with different USB storage devices and so on, trying to get it working.
Yeah, that's some setup time to get it running. But I guess over the new OpenBSD release, there will be more things working.
Yeah.
And yeah,
but there's lots
nice
of detail
for such a thing. And I guess we'll probably see an update for that one or some new use cases once more people check out OpenBSD on the Raspberry Pi.
At some point, I want to do something quite similar. I want to make a temperature sensor for the rack in my basement in that room down there where I keep all my computers because it gets awfully hot in the summer and I'd like to, be able to monitor it and graph it.
Yeah, with some little graphing components, see the, hot days.
Yep. And then we have an interesting paper here. Dennis Ritchie's paper, The Evolution of the Unix Time Sharing System.
For the history buffs.
Yes.
Yep, that's a good paper.
But, it says, this paper represents a brief history of the early development of the Unix operating system. It concentrates on the evolution of the file system, the process control mechanism, the idea of pipelines for commands, and some attention is paid to the social conditions during the development of the system as well. It says, during the past few years, the Unix operating system has come into wide use, so wide that its very name has become a trademark of Bell Laboratories. Its important characteristics have been known to many people. It has suffered much rewriting and tinkering since the first publication in 1974, but few fundamentals have actually changed. However, Unix was originally born in 1969, not 1974, and the account of its development makes a little-known and perhaps instructive story. This paper presents a technical and social history of the evolution of the system. So it starts back in 1968 and kind of explains how things evolved.
Yeah, it's interesting to see, looking back, what kind of things they thought, how would they develop, and then they,
Yeah, it's also interesting to look at which things changed and which things stayed the same. And
yeah, pretty much
how maybe they would have thought that it would, certain things would have stayed and they didn't, and some things they figured would get replaced and they haven't. Or how many ideas they had so far before their time, like the ideas of virtualization and containers and capabilities and all these other things that were, seem like very new ideas right now. It's actually, they came up with them back then and it just wasn't possible to do them yet.
Yeah, because the machines weren't that powerful enough.
Yeah.
But yet, it's good to, the thinking was there already, and people were creating the groundwork for these future technologies to evolve.
Yep. So it kind of steps through a bunch of the different areas, starting with the origins of, how Unix got started, and then looking at the PDB-7 and creating the Unix file system. Then they look at how process control works. So actually starting and stopping processes, putting stuff in the background and the forking in children and so on. Then IO redirection, how, take the output of this and send it to a file or whatever. Then the advent of the PDP-11, which was a much bigger computer compared to the PDP-7, and then porting Unix over to the first PDP-11 system, and then they get to the big one, pipes. You know,
Ooh, yes.
it's interesting how something's so old and basically it still works exactly the same way, and it's still one of the most powerful things about Unix. It's just
even the commands
taking the output of this command,
same, or mostly the same today.
taking the output of this command and making it the input of the next command, and its output is the input of the next command, and then in the end you get what you're looking for. It's quite amazing.
Chain of pipes.
Then they talk a bit about higher level languages, doing stuff in things other than C and so on, and then have some conclusions. The important one...
Yeah, the conclusion is nice.
But one of the conclusions they have here kind of... definitely, if you're a younger person and you're looking at some of this Unix stuff and being like, this is so old-fashioned, why do you guys do it this way? It can kind of help explain it a little bit.
We have a little bit of a history built up over the years.
One of the comforting things about old memories is their tendency to take a rosy glow. The programming environment provided by the early versions of Unix seems, when described here, to be extremely harsh and primitive. I am sure that if I was forced back into a PDB-7 today, I would find it intolerably limiting and lacking in all the conveniences. Nevertheless, it did not seem so at the time. The memory your memory fixes on what was good and what lasted, and on the joy of helping to create the improvements that made life better. In 10 years, I hope I will look back at the same mixed expression of progress combined with continuity. I remember my first computer, and then each time it advanced, it seeming like such a big step. But yeah, if I had to go back to using DOS now, I'd be like, what is this? How can I do anything?
Yeah, you kind of get used to a certain standard of, operation in the operating systems and tools and utilities.
Yeah. But this week's episode is brought to you by IX Systems. If you need a new server for open source, these are definitely the people to talk to.
Yep, and you can check out ixsystems.com/BSD Now to get the ultimate guide for buying a new server for open source. Which gives you a couple of things you might ask for your new server, things you might think about or need to think about, and also ask your server vendor whether he can provide these things.
And then they'll say no, and then you go to IX Systems, yes. It's where my company goes for all of our hardware just because they make it so much easier. I'm getting some more video encoding servers, and they're going to be delivered directly to a data center in a country which I do not live in, and it means I don't have to go there. But the important thing is I'm not going to have to pay a bunch of remote hands fees to set up the servers. IX is going to build the server for me, test it, and then configure it exactly the way I want, and even down to labeling which Ethernet port is the one that's configured for the internet. And
BIOS settings.
Yeah, all the BIOS settings, everything. So then when it gets delivered to the data center, the people there will put it in the rack, see the label, plug the Ethernet cable in the right spot, and boot it up, and it'll come online and it'll be going. And I don't have to, I don't have to wait a while I wait for a technician and then spend a bunch of time on the phone with them and paying them, $100 or $200 an hour for emergency remote hands to hook up the server, because they just rack it, plug it in, and it's good to go. It just makes my life so much easier. And if something does go wrong, I know the white glove support and the create RMA process at IX means that the problems will be solved very quickly and as easily as possible.
Yeah, and they have some great technology partners. If you go to ixsystems.com on the partners link and technology partners, these are the big companies that you should know. And, from Intel to AMD to all these server and storage partners they have. So these are big names that are cooperating with IX Systems.
It makes a difference when the hardware vendor you're talking to actually has a relationship with a company that makes the HBA that's controlling your disks. So if there's a problem, maybe you can get a beta or a patched firmware for it, or even a partnership with IX's relationship with Western Digital is so good that Western Digital let us have Meet BSD at their office a couple of years ago. We know that if IX needs to talk to Western Digital to get you the right firmware for your workload, they'll be able to do it.
We're joined today for our interview section by Kris Moore, Director of Engineering at IX Systems and former BSD Now co-host.
Yeah, you might remember me from such podcasts as BSD Now and BSD Now.
Yep.
Right? Well, thanks, Benedict. I appreciate being able to come on the show today.
Yes.
Yeah, thanks for coming back to us in it's like a month. We just figured out since last we interviewed you. So tell us a little about what you've been up to since our last interview.
Has it only been a month? It seems like
I guess
6 months,
more
year,
like
something like
6 weeks, I guess.
Too short.
It'll be about 6 weeks since we actually recorded it, but it aired on the 15th of March, and it's now the 19th of April.
Just spent a week and a half out in California. I mean, I'm ready for 2017 to be over. It's been busy. So yeah, in the last month, I've just been really busy at work at IX. I just recently got promoted to Director of Engineering over at the company there, and taking over more of FreeNAS and TrueNAS, and of course still overseeing the TrueOS project. And obviously there's been a lot of big changes announced in the last couple of weeks, which I'll be more than happy to talk with everybody about today and kind of give everyone the scoop what's going on.
All right. I guess that makes sense. It's the question on everybody's mind right now, so I suppose we should start there, right? So can you tell us what happened to FreeNAS Coral and how it got downgraded from a technology to a technology preview? So it was like recalled. Did it have E. coli in it?
Right. Well, first of all, it's not Coral, it's Corral, Wild West and corralling.
So whose idea was it to name it like it was a Mac OS release or something?
There was a few people behind the name, and a lot of people really like the name internally. So we're still trying to figure out what's going to happen with all that, right? But so what happened with it? It's a long story, but I'll try and condense it down because I've told it maybe to 30 people one-on-one now in the last couple of weeks.
Don't skip all the good parts.
I'm glad I can. No, I won't skip all the good parts. We'll definitely hook you up because, of course, I have a special place in my heart for all the BSD Now listeners. So what happened? So for those who want the kind of we'll give you a little bit longer story. So 10, it was originally FreeNAS 10 before it became FreeNAS Coral, right? So about a couple years ago, they were working on FreeNAS 9 and decided, hey, we're going to start over with everything and start from scratch. So new middleware, new UI, new everything essentially, right? Except for the OS, and even parts of that got changed before it was all said and done. So the FreeNAS 10 team kind of went into a hole and did their thing for quite a while, and that was all under Jordan Hubbard when he was CTO here at IX. And then finally, after a few delays and several UIs later, for those who've been following along, I think the UI that shipped with Coral was the third UI that was under development for it. So obviously there was a lot of rockiness to get over there, right? And so they had some issues, and they were eventually able to come out with what was Coral about a month and a half ago. So since then, though, what kind of happened afterwards is what makes it even more interesting, right? So Jordan left IX shortly after that. I think he put in his resignation a week after release. And then there was some doubt, what are we going to do going forward? So Matt Olander, which I don't know if we've ever officially interviewed Matt for the show, but have we? I know we've all talked once. BSD.
I think it was at Meet BSD once.
Well,
maybe not.
It might have been. But if you've ever come to any of the BSD conferences, BSD Can, Meet BSD, you've probably seen or heard of Matt there. And he's of course, one of the co-founders and owners of IX and was the CTO before Jordan. So he stepped back into the CTO role after Jordan announced he was leaving. And then I, of course, had been already kind of leading the legacy FreeNAS team, which was FreeNAS 9 and TrueNAS 9, our enterprise product based on FreeNAS. So after Jordan left, we had to take a little bit of time and sit and actually kind of review what we had. So we're looking at Coral going, okay, there's some cool new stuff in here. So there's a new UI, which everybody likes, flashy UIs. But one of the things that was already troublesome there was Jordan had already announced they were going to redo that. In other words, the UI that they shipped with was based on Montage, which if you don't know what that is, don't feel bad. Most people don't anymore. It was a UI framework, so maybe akin to like Angular or something, right? And what happened was in the last iteration of Coral's UI, they went with this Montage framework, and it was going to be awesome. And then 6 months, I think, into the development, the company behind Montage went bust, like just went out of business, right? So Jordan had hired some of the Montage UI guys, and we were going to try keeping it going. But even they knew, and he was announcing publicly, like this UI is not going to last forever. We're going to have to replace it because the upstream's gone. That means we're now on the hook for keeping all the browser compatibility going. And there was a reason why the Corral UI didn't work properly on browsers like Firefox, or had a lot of issues on the non-Google blessed Chrome, using the open source Chromium, for example. So, we're already looking at it going, okay, we're already on the hook for a new UI. And then now we have all the other new bits. We have new middleware. We have, changes to the base system, extensive changes to the base system. A lot of stuff had been replaced and rewritten there from scratch. And so we had to make a call. We kind of reviewed the code and said, okay, we have this new thing, which has some cool new ideas. And then we have the old legacy code, which isn't legacy. It's still being developed and actively hacked on and has since grown things like an asynchronous middleware. We have that code, which is shipping on enterprise products today, right, on our TrueNAS releases today, and is solid and vetted and just works. So we were like, okay, do we take that? How can we merge the two, right? So there was a lot of internal agony about this. Do we merge the two products? Do we try and take the enterprise stability of the 9 series and merge it with a new UI, or bring in some of the Corral code? And again, a lot of heartburn over this, right, internally here at IX. I won't make no bones about it. This was a gut-wrenching decision, right? Anytime you have to back off a new release or a new product, like, you're going to do that for real reasons, right? That wasn't just something we decided over a beer just one afternoon, like, hey, screw it, we're doing something else. Right. No, this was a gut-wrenching decision. But we were looking at Corral going, okay, so the UI we have to replace. The other big feature people really liked was Docker, which, again, we're on BSD Now here, so I realize not everybody here is a huge Docker fan, but there's probably some out there who are. And Corral introduced that idea of being able to run Docker containers on FreeNAS, which the way they were doing it was actually using Beehive. They were using boot to Docker and a VM, and then kind of just exposing some of that functionality into the Corral UI.
Right. So the big part of that was to be able to run apps as just, all set up, almost like a plugin that was already shipped for you, just having the entire array of stuff that's available in the Docker repo, and you could just run it on top of your FreeNAS?
That was the goal, right? Was when Jordan was looking at it initially, they just wanted access to those couple 100,000 Docker containers that are already out there, that are in the community. And they wanted that ecosystem, right? So the way they came up with to do that was, well, let's use VM functionality in Beehive, and then they did a shim layer in between using Plan 9FS, which we reviewed that and talked to some of the engineers behind it, and there were some issues with the code there, that weren't quite making it ready for enterprise. But so that was kind of the other big party piece. And then the last party piece was just, of course, the ability to run VMs at all, which if you're a FreeNAS user running the 9 train, and if you've been running the nightlies anytime for the last 3 months, you'll see that we actually imported that into 9 already. So that was already on the roadmap to come out in the last 9 release, right? We had all the same Beehive functionality coming in. Of course, it's on the 9 UI, but the core underpinnings were the same, except for P9FS. We didn't really go that route, and we were looking more at using NFS, which is definitely slower, but also enterprise and vetted. So anyway, so we looked at these two products and said, okay, so with the team we have, with those who are left at IX who can work on this, what can we realistically do? And the decision was made, well, hey, taking and putting a new UI on the 9 and then bringing over some of the Docker functionality in the form of, say, Rancher. For those who don't know, have you guys ever run Rancher before or run Rancher OS?
Never.
So there's a bunch of, Rancher's not the only one, but there's several real small Linux distros out there, or Linux spins, that basically give you a nice web interface to run Docker, right? And so Rancher would be one of those. So we're looking at using something like that. I think, was there another one? Portage, or not Portage, but I can't remember the name of it now. I just saw it the other day. But there's a bunch of these out there, right? Different companies are behind them. And they all have some really cool functionality that we're like, if you could just run that in a VM on FreeNAS, that would be really effective and efficient way to run your Docker containers, right? And with an interface better than Corral even kind of dreamed of offering at the time, right? They've already, they're solving problems specific to Docker, whereas we're still dealing with just NAS functionality and things that make FreeNAS, right? And we don't want to have to duplicate effort. These are all open open source projects too. So we looked at marrying something like that with a new UI to 9 and said it's going to take a lot less time and engineering resources to get 9 up to the point where we now have some of those party pieces Corral did than it would take to get Corral to the point where we felt like it was enterprise worthy. In other words, something we could actually ship on a true NAS, or something that we felt comfortable running internally on all of our infrastructure. It just, there was a lot higher ramp up time to make the current Corral code base do that, and then we would end up having to rewrite parts of it to be like 9 again anyway. So if you're going to do that, you might as well just bring some of the cool technology and ideas of Corral into the 9 series and move forward as the soon to be announced FreeNAS 11.
So you don't have to throw everything away. It's just get the best bits out of each.
Correct. Yeah, try and bring the best bits out of each. So if we can bring some of the cool improvements they did to Beehive in the FreeNAS 9, definitely going to do that. If we can put a new UI on it, which they had to do anyway for Corral, we're going to do that. Matter of fact, we've already started that. So if you're running the nightlies right now, you'll see we have a link on the login screen for a button that'll let you try the new UI, which is Angular based, which is a very popular framework used all over the place and looks like has a bright future ahead of it. So we've already started the work to get this new UI spun up. And the plan is, another thing about doing it this way is we want to be able to support both UIs. There's a lot of people who, while the old UI is, maybe a little kludgy looking, or it's just old, right? It's showing its age, but it works and it's well understood and it's documented, all right? But now we can pair a new UI with it, and we don't have to force you to go to the new one until you're ready. Like, we can support both stacks, and we can keep that there until the new UI is proven and vetted and is just of a quality where we feel comfortable deprecating the old UI at that point. So.
Okay.
Made sense to try that and go a little bit different route here. But again, we understand a lot of people are still fans of Corral, so we're going to keep that in mind and try and bring some of the really cool concepts it introduced.
Yeah, that's the question. For, let's say, what's the path forward for users who have already upgraded to Corral by now?
Well, so if you're upgrading to Corral, Corral was based on FreeBSD 11 stable, so it's going to have a little bit newer zpool version than 9.10.2 has. So the next release of 9.10, I guess it was going to be 9.10.3, but I'll announce here we're going to be renaming it to 11.0. That will have the same version of FreeBSD stable under the hood, actually a little bit newer version even, which will allow you to import your pool, so all your data is safe. You don't have to worry about that. You can bring all your bits back. That's
still
exactly
the same at the core. Yeah,
it's still the same at the core. So we're going to be able to bring back your data. Heck, your VMs will still live there. So if you had ZVols set up with VMs on it, all that's there, and you can easily set those back up and import them into the 9 UI, either the old or the new one, and move forward. So we're working on that. We want to try and make that as painless as possible. Of course, it's only been about, I think, a week today since we announced this. So we're still kind of figuring out behind the scenes what all that looks like, and we'll be talking more about that in the future, of course. But some of the folks on the forums have done an excellent job documenting how to do this already, how to migrate from Corral to the current nightlies and get on to the 9 tree. So again, there's info out there to do it if you're ready to try doing it now, but otherwise we'll try and provide more of that going forward.
Yeah, it's not a dead end. People have a way to,
data. Yeah. Again, it's not like we locked you into some version of ZFS that only ran there. It does have some particular little nits here and there where you might have to go turn off a flag or something you turned on, but it's not unsalvageable. You can definitely get everything back.
Yeah. That's good to know.
So for people that have started using Corral already, like, what do they do about the features that don't exist in 9.10 yet? Like, if they have Docker stuff, is it possible to keep it going, or?
If it's working for you and running, you don't have to shut it down. It's not like we're going to remotely reach in and disable your system.
Right, but you're going to want to be able to upgrade it eventually, right?
Of course. We're not planning on supporting Docker migration. Docker, because the way it was implemented in Corral, it's going to look a little bit different in 9. So that's not going to be a one-to-one match where we can just seamlessly migrate over. And the same thing happened for people going from 9 to Corral. Corral didn't even support jails at all. Like, there was no functionality in the UI for doing jails or jail-based plugins, so that functionality is lost. So we're still going to have to take a little bit of a hit there, and you might have some pain going and setting up your Docker containers on the new thing once 11 releases. But it should be doable as long as you remember which ones you set up and how you did it, and the data is stored on your pool. At least your data and your configs and all that are there.
Okay. So at this point, can you discern or figure out what are the future directions that you're not going to take with FreeNAS?
Sure.
Or is it too early?
Well, actually, somebody in IRC asked too. They were asking which Angular we're using, 1 or 2. Actually, neither. We're using 4. So Angular.io. I'll just answer that really quick. It's the TypeScript version, so it's the 4.00 version of Angular. So
you want to be able to keep going forward with the UI, right?
That's right. That's right. So we're not going to start on something old. We're going to go ahead and use the newest stuff. So future direction of FreeNAS. So obviously we got a little bit of work to do to get us kind of past this corral road bump right now, right? We got to get the new UI in there. So that's going to be kind of top priority front and center. And then also bring in the VM functionality and make that very shiny and solid and be able to run Dockers out of that. So those are the 3, I guess, things, if you want to say, that we're really working hard on right now. Of course, part of that was we had an update to jails already scheduled. The new Python IO cage is coming in here in the near future, and we're hoping to make that just as much of a first-class citizen going forward, because a lot of us here are BSD fans and still believe in the tried and true jail technology. And there's just a lot of cases where you don't need to spin up a whole VM. You want a lightweight jail, and there's no reason not to do that. Don't take the performance hit of running a fully virtualized stack. So anyway, that's some of the stuff we're looking at on the immediate roadmap. Beyond that, there's some other cool things in the works. So for those who don't know, we've added for the upcoming 11.0 MinIO support, which I don't know if you guys have talked about it on the show. Really. It's only been 6 weeks. So it's another open source S3 compatible object store written in Go. But the cool thing is it uses erasure code, and it also lets you go distributed. So you can run nodes of like 4. You can run 4, 6, 8, 16. You can basically distribute your workload across a common namespace, which is very cool and has some really interesting possibilities for us.
Yeah, so you can take multiple FreeNASes and make them exposed to your app as if it was Amazon's S3.
Correct. But the cool thing is MinIO does some other neat stuff. It even has a MinFS where you can mount it at the Unix shell. You'd be able to mount it like it's a local file system and serve stuff or run services on top of that. It has all the POSIX locking, and it's really cool. They got some neat stuff going on there, but that's one of many, and that's kind of some of the direction I'd like to see FreeNAS to grow some capabilities in that direction, where it's more multi-system aware, multi-node aware.
Interesting.
When do you expect to see FreeNAS 11?
Current ETA is May the 1st. Okay. So may the 1st be with you. Or I guess May the 1st,
like right? 11 days?
Yeah, well, 9.10.3 was already just about ready to go into feature freeze and branch at the end of this week. Matter of fact, we're still targeting that. The only thing really new going into it at this point is the 11.0 version, right? Which is
the first important thing is getting back to version numbers that make sense.
Yes. We're looking at this as an opportunity to kind of, pay for our past sins and get us back to a proper versioning scheme. Because for those who've been following along, we had 9. And then we had 9.10, which was actually FreeBSD 10.3 running under the hood. But for political reasons, we couldn't call it 10 because 10 was the new thing, which ended up being Corral and didn't even ship as 10. And so we're undoing some of that now, right? And we're going to get back to 11.0, which will be the first release based on FreeBSD 11.0, so a major version bump. And then, of course, after that, we'll do 11.0-U1 for Update 1, Update 2. Those will be bug fixes only. And then 11.1 for new features. So we'll try and we're going to try and branch off the master tree roughly every quarter. So you'll get an 11.1 and 11.2, and that's when you'll see new features show up. But once you've upgraded to 11.0, for example, the update branches will just be bug fixes to your existing feature set.
And so this is, quick question, I guess. Is FreeNAS 11 going to be based on 11 or 12? Okay.
It's based on 11. It's running 11 stable. So
have you cherry-picked anything?
Don't get me wrong.
In particular, say, ZFS compressed ARC?
Yeah. Actually, yes. So some of these things have definitely come in, and we do cherry pick things from head. So for those that don't know, we have several FreeBSD committers on staff here. Alexander Moten, or Mav, is a good example, and he's really good about making sure stuff gets upstreamed, and then we cherry pick the important ones back into the FreeNAS code. We're not running current, although if you're really on the adventurous side, we do have builds of it. So if you go to our download site, there are builds of FreeNAS, I guess the 9 tree running on 12 current. and I update that roughly every month. So there'll be nightlies built upon that, and you're welcome to run that. And there's a train you can stay updated with, so you can run FreeBSD on 12 head if you're really adventurous. Of course, we encourage people, if you like to do that, do it. Give us bug reports. We may not get to them right away, but it's good for us to know kind of what's coming down the pipe, right? And know that, okay, 12 is going to add this or broke this or something, and we can fix it long before it lands in the official release.
Yeah. So are there any new developments on the TrueOS side that might, say, influence where FreeNAS is going?
So I've gotten a little busy to work directly on TrueOS. To be honest, it's Ken here, which we've interviewed before, Joe Maloney, and JT, our producer here, actually. They're the three guys who are doing a good 90% of the work on TrueOS at this point. And they're definitely working hard still on the new Lumina desktop and trying to get that up to 2.0. And the big thing there will be eventually kicking out to the side the Fluxbox window manager and shipping with our own homegrown one. So Lumina will be a proper desktop with its own window manager as well.
What about, like, say,
on the TrueOS
SysADM or an API to manage multiple FreeNASes?
Sure. An API to manage multiple FreeNASes. We don't have plans to put that into TrueOS yet. We are adding APIs to FreeNAS already. So
but those will be unrelated to SysADM then?
Those would be unrelated to SysADM at the moment, unless we decide to hook those up at some point, which we have some stuff we're talking about behind the scenes of how we would do that. But that may be more on the commercial product side. But if you don't know, FreeNAS does have a great API already. There's a fully documented REST API that you can use, so api.freenas.org. And then, of course, the new middleware does WebSockets as well. And there's quite a bit of API goodness there as well. It lets you drive around your FreeNAS boxes. So if you're a scripter or a web developer, there's definitely a lot you can do to drive your FreeNAS around remotely at the moment.
Okay. So with all these new growing features, sometimes that are happening at a very rapid pace, do you think that some users prefer something less fast-moving sometimes?
No, that's definitely a valid thing. We've actually just had some discussions about this for the TrueOS side specifically, because
like obviously how fast it is.
Yeah, we're tracking current pretty quickly, right? But some people we're finding, maybe don't want to have to do package updates every month. They want to do something a little slower. So we're talking about slowing our stable branch down at the moment. We haven't officially made this decision, so bear with us. But we're discussing moving it to maybe a 6-month cycle. So once every 6 months, we'll bump the stable version, even though it's based on current. You'll have your full package set for 6 months there. And then if you go to the unstable branch, that's more of your weeklies, right? Where you can get the absolute bleeding edge and maybe virtual box breaks every now and then and so forth and so on. It's a really fine balance, though, on the TrueOS side in particular, because we need the features of current that are coming in for driver support, right? The DRM work, for example, hasn't even landed in current technically yet. We're pulling that from elsewhere. So, it's a little bit of a catch-22, right? You need it on one hand, but on the other hand, you don't want it moving that fast. So we're trying to find a balance between them. So we'll still develop against current, but we will lock it down and only update the stable branch less often. So there's a little bit less churn there. And then for the more adventurous who need that absolute bleeding edge, or for example, just bought a brand new laptop and that's the only thing that supports it, at least they have an option, right? Yeah. So it's not like we can stop chasing the head tree because we just need that.
And then what about for FreeNAS?
So for the FreeNAS side, the development model is slower there, right? We're not tracking head necessarily. Yes, we have an experimental branch, but we're not forcing that down anyone's throat. That's not going into a release. The release is just tracking FreeBSD stable under the hood. And typically we're actually syncing it right now weekly because we haven't released on it yet. But once we release, that'll slow way down. We won't be pulling it as often and probably cherry picking more things. But as far as features go, on the current plan going forward with 11, or I guess 9.10.3, which is now 11, features-wise, the new work's going to be going into the UI, which again doesn't remove or change the old UI. So if you're somebody who's a little more conservative, it's not like we're changing, pulling the rug out from underneath you or changing stuff on you, right? You can still keep on going and only switch and start using the new UI when you're ready or when it's feature complete. As far as other features go, the biggest stuff going in is, again, VM functionality, which it's one of those things. If you use a NAS and you don't care about VMs, you don't have to use it. It doesn't impact anything else you're doing. And then again, adding something like MinIO, that's an optional service. It's again something that's just available for you to turn on, just like any other service in FreeNAS. I'm sure a lot of people don't use FTP or AFP, but we still support it, and we'll throw things in there like that because there is a significant percentage of people who want that functionality.
Yeah, it's always a question of what kind of users demand which kind of features, and how loud they are about
That's
that.
right. That's right. We can't stop development, right? We can't let this stagnate.
No, of course not.
New exciting technology coming out all the time, new hardware to support. So we gotta chase that a little bit. But for our stable FreeNAS platform, we're definitely not going to be pushing as often. You'll be looking at a new dot release again. It's been in the last year. It's been mostly quarterly, is what we've done. It looks like. I think last year we did 3, so it wasn't even really quarterly. But that seems to be a pretty decent pace, a trade-off between I don't have to update it that often versus new stuff's coming that I might want or need. And to be honest, a lot of people just don't update. I mean, it's a NAS. Right. How often do you guys sit in your NAS user interface and click them out?
They probably use from their commercial NAS. They get 2 updates from the vendor and then nothing else, and it has to run for years.
Right. And a lot of people treat their FreeNAS that way. I mean, if we look at the update stats and see how many people are still running 9.3, it just bears it out, right? A lot of people, the point of a NAS is you set it up once. And so that's another thing. We don't need a super whiz-bang UI. We just need something that looks decent, it's intuitive, it's easy to set up and use. But once you've kind of got it dialed in and set up, you're not living in that thing every day, typically anyway. Yeah, if you are the abnormality here, because most people just set up their NFS shares or their Samba shares and then don't touch it again. But obviously we want to try and support both use cases, so we're going to mix it up a little bit. But again, there's nothing wrong with just installing it, getting set up, and then only touching it once a year and updating when you feel like it.
Yeah, the nice thing is that ZFS has new features that come out, but they're not at an overly rapid pace, and most of the times you don't necessarily miss them that much. Depending on the use of your FreeNAS, the new compressed arc feature will, I think, be a big draw for people to upgrade, because if your blocks on disk are compressed, like say your VM images, lots of the data in there is compressible, all of a sudden you fit a lot more cache and RAM with the same amount of RAM, and that increases the performance a lot.
Yeah, and those are always going to be the type of things we're going to try and pull into FreeNAS very quickly. Again, if you don't upgrade, you don't have to worry about getting that stuff, but that's a big value add. So we're going to try and pull stuff like that in. For example, the crypto patches that are going around for possibly going to OpenZFS. As soon as that lands on FreeBSD, you can bet I'm going to be pulling that into our tree, at least for the nightlies right away, because that's a hot feature. Yes. We would love to have per data set encryption. So speaking of Alan, do you know if anyone's porting it yet?
I've started a quiet project to get the needed bits that aren't ZFS into the tree for that. Currently, in ZFS, the native crypto supports 2 different encryption algorithms. Only one of those exists in FreeBSD today. So, without having to do much, we'll at least be able to use that one. But ideally, we'd want both so that FreeBSD can import an encrypted pool from Illumos.
Yeah. Sure, or Lumos or Linux or whatever. It would be nice to have one crypto framework you could use across those OSs.
Currently, that's what they're doing on Linux. They imported the Illumos crypto framework thing into Linux.
Okay.
Although,
so we got to do this.
Well, what I was looking at doing was just using the Open Crypto framework that FreeBSD already has, that's used for IPsec and Geli and a bunch of other stuff, and just hooking that up, because it's fairly straightforward to swap the calls to the Illumos crypto framework to the calls to the regular Open Crypto framework.
I'll have to talk to you about this offline, or maybe at BSD Can or something. We might be interested in helping with that, because again, that would be a hot feature.
If you remember a couple of weeks before you quit, when we interviewed Konrad from Poland, he's supposed to help me look at getting the missing crypto algorithm done as well.
Oh, fantastic. Okay. But that's what I mean. ZFS features, in a NAS, definitely. We're gonna definitely pull those in. And I did see I had somebody ask a question in IRC too about jail plugins. So yes, we will still have jail plugins in 11. They will not be based on the old crufty PBI format stuff that's been there in FreeNAS for years. IOCage supports a new format of plugins, which is basically just a JSON manifest that says, I want FreeBSD 11 base, and then I want these packages, and here's a GitHub repo, which we call an artifact repo, that maybe has post-install scripts or configuration files, that kind of stuff. So a heck of a lot easier to create plugins for. Matter of fact, I think I did 3 in an hour a couple weeks back. Like I was like, oh, Plex, that was 10 minutes. So we're going to make it a lot easier for people to swap and create these. Again, if you have a GitHub account, you can put the artifact files up, and it's usually just a few kilobytes of a post-install script that turns on rc.conf knobs. So anyway, that is still coming. There will be jail-based plugins available because, heck, I like them, and they're fast, and being able to mount nullfs into a jail is still going to be the most performant thing you can possibly do. So, especially running for something like Plex.
So the chat room also wants to know, is there a beta of FreeNAS 11 that people could start trying out?
It's not so much a beta as it is our current nightlies. So we just
So if you want to use 11, download 9.10.3 nightly?
Well, 9.10 nightlies. So if you already have FreeNAS installed, on the update section, you have a drop-down that lets you pick which train you're on. So you have the stable train, which is releases, and then you have a nightlies train for FreeNAS 9, and that's had FreeBSD 11 in it for, 3 months now. So you can just switch to that, and boom, you'll be essentially running what's going to end up being the 11.0 release here in a couple weeks.
And then the other question was, which upcoming ZFS features, maybe other than the crypto stuff, are you looking forward, and how might they change what TrueOS or FreeNAS end up doing?
I still would really like to have the persistent L2 ARC in at some point. Like, I don't know if that's ever going to land.
So I talked to Sasha Kiselkov, and he had some other patch that needed to go first, but then he'll be working on persistent L2 ARC again.
Okay.
So, yes. As Josh Petzel and I kind of talked about a little bit at the the FreeBSD Storage Summit in February, for a couple of these things, it seems like part of it they're just stalled at the testing phase, and that maybe getting these ported to FreeBSD. So, some of the work when that code eventually does land in upstream happens is already done in FreeBSD, but also FreeBSD is a little more agile and a little bigger user base than Illumos, and might allow some of those features to get the testing they need before, so that they can actually go into OpenZFS. But at the same time, we don't want to give ZFS if there are bugs in any of this stuff, we don't want people mucking up ZFS or making ZFS look bad.
Well, right now we have this reputation that even on current ZFS is solid.
Because we import the stuff that goes into Illumos, and Illumos says somebody has to be using this in production for 6 months on their OS before we'll accept it in our repo.
That's a long time. But it has to write in there.
But hey, for your file system, that's the kind of paranoia you want.
Right? And every bit of code has to be reviewed by 3 subject matter experts first. Like if you ever see if you look at the commit that we'll talk about later in the show, when the ZFS compress send and receive, when that went in, the list of people who reviewed it was rather long, and it's because that needs to be right, because that's the backwards compatible format as well. So that means that can never change.
Sure.
You want to be very thorough about that.
Compress, send, receive would be a nice one to have as well. There's
Josh imported cool that one went into FreeBSD's vendor branch the other day, so it should land in head very soon.
And I imagine if once it lands in head, or at least shortly after, we'll probably definitely take a serious look at pulling that into stable. It won't make it for 11.0 again, because we're going to probably branch that off this next week, or by Friday, I think is what we're looking at. But for 11.1 and for the nightlies, we'll probably pull it in really quick there and let people start testing it and beating it up.
Well, because
see how it's working.
For that one, you'd have to make changes to your replication tools to actually use it.
No, we'd have to go into the middleware to the replication engine and definitely add support for it.
Because then you need to check that the machine receiving it supports it, because otherwise you don't want to enable it, right?
Correct. So there'll be some stuff we have to do to make that supported, but that's the kind of stuff we like having in FreeNAS. Those are the kind of features I think, heck, if we didn't pull it in, somebody'd be making a ticket for it 24 hours later, like, oh, FreeBSD just got this. Why don't you support it yet? Why isn't there a release of FreeNAS with it yet? Be patient. It's coming. You know how this is. Everyone, see what I mean about the shiny? Everyone wants the new shiny thing too. And you're telling me like, well, can you slow down? Or
it's like, can you slow down, but still take all the ZFS stuff and all the drivers and like everything basically, except for, I don't know.
Except for, I don't know, what package changes?
It's like, I want all the latest stuff, but I don't want to have to upgrade. It's like, well, that's what the boot environments do. It makes the upgrading not a risk, right?
So one of the things I'm still looking at, I have a feature branch set up to switch us off the Grub bootloader over to the BSD loader. I'm still very interested in seeing that. It'll integrate a little better with Beehive. So stay tuned for that. Hopefully, I might merge that in after we branch for 11.0 because I don't think we have enough time to adequately get it in and test and vet it on a bunch of platforms. So, but I would like to get that in here in the near future so that Grub goes away. I've been wanting to get rid of Grub forever. Working on it. So we have a feature branch with that if people are interested and can ping me if they want the address where they can grab those ISOs to try it out.
Cool.
Okay. Since we've just come out of Easter, are there any Easter eggs hidden in the programs that you've written over the years that people might want to search for?
Well, I've never actually put an Easter egg into a program unless I want to call a bug an Easter egg or something. But no, honestly, I can't say I've ever personally done that. Now, I have seen FreeNAS developers have put little things in here and there, hidden Easter eggs, but I don't know where they're at, so I guess they're still a hidden Easter egg.
You're still searching yourself,
right? I think there might be some command line flags to some things that just have some funny output and stuff. So look around for that. Maybe that's a good post to the forums if you find one. Give people a chuckle. But I have not personally put in the end, no.
Yeah, okay.
Okay. Was there anything else you wanted to talk about before we let you get back to working on FreeNAS 11?
Right? Wow. Well, there's always so much to talk about. Now, I think we covered just about everything here with what's going on with Corral and FreeNAS 11, and TrueOS is still releasing with new stuff, so definitely check that out. I think that's about it. Of course, it's weird being back on here again. It's only been 6 weeks.
Already out of the habit.
But I know, right? I'm like, how do I do this again? No, it's been really good. I'm definitely enjoying it, and you guys keep up the good work. Keep the show rolling. I know the community definitely appreciates it. So, got to have a source of weekly updated BSD news, and you guys are fitting that need.
Yeah. All right.
Okay. Well, thank you guys very much for having me on. I appreciate it, and enjoy the show, everyone.
We'll call you in again in like 2 weeks or so.
Oh, great. Thanks. Yeah. Change my cell phone number. Thanks, guys. Yeah.
This week's episode is brought to you by DigitalOcean. Do you need a FreeBSD computer out in the cloud somewhere? Well, you should check out DigitalOcean because you can get one starting at just $5 a month or 0.7 cents an hour. For that, you get
very cheap, but great features.
Yeah, for that, you get your 512 megabytes of memory, a dedicated core, 20 gigabytes of SSD storage, and a terabyte of transfer. Or for $10, you can get double all of that. And it means that you get everything you need to try out FreeBSD or build a mail server or build an IRC gateway, Benedict.
I will
yes.
soon. Because the nice thing is also that it's on DigitalOcean, you can get the first and only all SSD cloud. Mm-hmm. So there's no hard disks anymore. It's all SSDs there. And all these compute instances or block storage, everything runs on SSDs in DigitalOcean's cloud. And they also have a simple API to control your droplets. Like if you have 10 or 100 droplets at one point, then you might as well use an API to control all these, like in a command line fashion.
Yep.
Another thing is that they also have a highly available storage solution. So in case you run out of storage space in your little droplet or in your droplets that you might have, you can always update to a maximum volume of 16 terabytes to a droplet. That's all.
Yeah, so you can buy storage separate from the droplet. There's a couple of advantages to that. You can choose exactly the size you want rather than the sizes that come with the droplets. So whether it's 100 gigs or a terabyte or 16 terabytes, and you pay per gigabyte per month. But the other thing is you can also detach it and move it to a different droplet. So, it's not tied to one specific droplet. It's separate, which is great if you say, oh, when it's time to upgrade, rather than upgrading in place, I'll just throw away my FreeBSD 10.3 droplet and build a FreeBSD 11 droplet, and then reattach my storage. It allows you to easily upgrade and downgrade the size of your droplet without affecting your safe storage.
Yeah, and they have data centers around the world. So in the US, it's San Francisco, New York. In Canada, they have Toronto. Europe has London, Amsterdam, and Frankfurt. And in Asia, there's Bangalore and Singapore data centers for you available. And for each of those, you can get a nice speed test to see which one is the best for your location.
Yep. So you should check it out. And if you do, make sure you use the coupon code FreeBSD Now, and they'll add an extra $10 into your account so that you can keep trying out the droplets without having to spend more money. So, on to the news. Our first big story is one Benedict added here. The new ZFS compress send and receive feature has been imported into the FreeBSD vendor branch. So it's not actually in head yet, but the copy of Illumos code that we keep in FreeBSD to do the three-way merging into head has been imported. So that means basically committing it to head is now a work in progress. But there's two different features here that have come together.
Yeah, so for people who have never heard about that, what's the compressed ZFS send and receive?
Right, so this feature was envisioned a while ago, but was required the compressed arc feature before it could be built. So this takes advantage of the new compressed arc feature, which if you don't know what that is, it means that when you have compression turned on in ZFS and blocks are stored on the disk compressed, with the new compressed arc feature, which is in FreeBSD current, when you read that block off the disk, what you used to do was decompress it and then store it in memory. Now what it does is store the compressed version in memory. The advantage is you can now fit a lot more data in the arc. So the ZFS's RAM cache can now contain, whatever your compression ratio is, more data. So, even though you maybe only have 16 gigs of RAM in your NAS, if it's all SVN checkouts like mine is, it gets a compression ratio of like 2.5 to 1, means I can fit a lot more in RAM. So what the ZFS compress send receive feature does is now that the copy in the arc is already is not uncompressed, it's the compressed version, when it wants to send the data across the network, it can just send the compressed version. Before it would send the uncompressed version. So that meant when you were doing a ZFS send receive before, you would basically take the data off the disk, uncompress it, send it over the network, then recompress it and put it back on the disk on the other side. This is bad for a couple of reasons, right? Not only are you wasting processor to compress and decompress it, but you're making that be more data over the network, and the network is usually the thing that's the slowest.
Yeah, the bandwidth and all that.
Yeah, so
but now,
by not doing that, you get better. So what a lot of people ended up doing before this was, take ZFS send and then pipe that into a multi-threaded version of XZ or gzip, then transfer it across the network, then uncompress it, then pump it into ZFS receive. So that would mean take compressed data, uncompress it, then compress it, then transmit it across the network, then uncompress it, then feed it to ZFS, which will then compress it. That's it's the definition of inefficient. Yeah, so now if you do your ZFS send with the new -C flag, it will transmit the data already compressed. The caveat is the machine your ZFS receiving on has to support the compressed send receive feature. If it doesn't, you just emit the -C flag and it'll still do it the old way. Nice thing about this is it's still possible to transmit to an older pool, right? So if you have your main system and a backup, you can upgrade the main one and leave the backup on the older one, and ZFS send will strip out the features you're not using. But with the -C flag, you'll be able to transmit it compressed and save probably a lot of network and other headache. The second change they introduced was adding long op versions of all the ZFS send receive flags. So instead of having to remember that -C is compressed and E is embedded blocks and capital L is for large blocks and all the other similar things, you can now use the long versions of the flags. The nice thing there is it also helps basically make your scripts self-documenting, right? Instead of, minus C or whatever, it's the capital R, which was the way to replicate all the children and stuff, is now dash dash replicate. If you want to include the properties, that's minus minus props. If you want the output to not be human readable, but to actually be the raw number, so instead of saying 11 gigs, it would be 12 billion so many bytes. That's parsable. If you want to enable the dedupe feature, that's dedupe. Verbose is verbose. Minus N is dry readable. Run. Large blocks is large dash block. Embedded is embed. Minus T, which was the one where you took a token to resume, is now dash dash resume. That one especially was confusing because R and capital R were already taken, so having resume be minus T was slightly confusing. It makes sense because it was you used a token was the parameter, but having it be dash dash resume makes a lot more sense. And compressed is dash dash compressed. So with that feature in there now, it's much easier to read a ZFS send receive command line and know what's actually happening.
Yeah, if you've written that a year ago or like in 5 years, then you already know, or still know, but just by reading it, what kind of options there are and what it's going to do.
Yeah.
Yeah, that's why I was so excited about all these changes. They're not there yet in head, but when they're in the vendor branch, they're in a good way to
it means basically
be integrated.
They're dealing with the merge conflicts and testing it, but shouldn't be very long before it's committed. There are also a bunch of other commits in the vendor branch there, updating man pages and a bunch of other things that will make it better. The man page ones especially take a bit of work because the man page format on a Lumos is not the same as it on the BSD, so the merge conflicts are boundless there.
Yeah, that needs some more.
It mostly is a matter of
format,
taking the text and rewriting it in the BSD man doc. But yep.
But when they land, we'll be certain to announce them, and we'll probably also do a little demonstration, depending on people's interest and how well it works by then.
Yep. So another interesting feature we have this week is a blog post over on Mysterious Code about granting privileges using the MAC framework. So MAC, which is the mandatory access control, is a thing that spun out of the Trusted BSD project, which was a DARPA-funded thing quite a few years ago. But it allows finer-grained permissions than what you get with a standard Unix permissions and the base system. So they say here, FreeBSD's kernel provides quite sophisticated privilege model that extends the traditional Unix user in group one. So in this example, they actually show how to give a privilege that normally non-root users don't have. That's the really nice thing about the Mac framework is there's a bunch of these little privileges that only root can do. And rather than having to run your server as root or give the user sudo access or something, the Mac framework allows you to change the requirements to your own, whatever that might be, to allow a certain user or a certain process or something to do something that normally is restricted to root.
Right. So you can define policies for users or specific services you're running.
So the Mac framework allows creating pluggable modules with policies that can extend existing base system security definitions. The struct Mac policy ops consists of many entry points that can be used to amend the behavior of the system. So in this particular case, they wanted to grant a privilege to change the real-time priority of a selected group of processes. So it's kind of like the nice level, but it's more important in the scheduler. And real-time priority allows it to basically not ever be interrupted. It gets all the processor time at once. So normally that's only allowed to be done by root. However, on Linux, they added a feature where you could specify a specific group and anybody in that group could set that. But FreeBSD doesn't have that. So he created one that does exactly that with the Mac framework. So this is the privilege check can be extended using two user-supplied functions, priv check and priv grant. The first one can be used to further restrict existing privileges. So priv check means you can lock down privileges even more, whereas priv grant works the opposite way, where you can give away a privilege that normally they wouldn't have. So the core of the module he created, Mac RT Prio, is dead simple. It defines a sysctl tree that provides two OUIDs. One, to turn this feature on and off. So it's just 0 or 1. And the second one is the group that you want to allow this permission for. So then the body of the granting function is even simpler. If the policy is disabled or the privilege that they're trying to get is not the privilege scheduler real-time priority, then we return the permission denied error. If the user is a member of the group set by the sysctl, then we return 0, which allows them to do it. So now any user in the group specified by the sysctl can change the real-time priority of a process, and anybody not in the group can't. Now...
Okay, I can see a couple of use cases for that.
So now you can adjust the real-time priority of a process without having to be root.
Nice. Yeah, that's definitely something people might want to use on their servers to give only a certain group or group members these elevated privileges.
Yes, or if you need to do something that maybe most other people don't. It's actually fairly straightforward to write your own. They have a link to their GitHub here where they have the source code for it, and you can see it's only a couple of lines. It's actually very straightforward. It just defines the sysctls to allow you to control it, and then implements the simple function, right? So the function's literally just, when we want to grant this permission, if the feature is disabled, return an error, or if the privilege they're trying to get isn't the one we care about, then not allowed. But if it passes both of those checks, and the group membership that we've set in the sysctl is not 0, which is the wheel group, then if the user is a member of that group, then allow them, otherwise permission denied. And that's pretty much all there is to it.
Yeah, straightforward, but has its functions. Yeah. And if people want to check out the Mac framework in FreeBSD itself, there is a nice handbook page introducing all these concepts for people to try out with a couple of examples.
There's a couple of existing policies as well. One of them, which I find quite interesting, is called port ACL. It allows you to specify users and processes and so on that can bind to ports less than 1024. So in the traditional Unix security model, ports with numbers less than 1024 are considered privileged, and you have to be root to listen on them. So this meant that a web server always had to be started as root. Now, most web servers then start a master process as root that listens on the port and then forks off the children into, say, a W user that does the work so that if something happens in the web server, they don't have root access. But, it still required you to have some process running as root. Whereas with the port ACL, you can change that rule and say, the W user is allowed to listen on port 80. And now, you don't have to have any root at all.
The other Macs people might have seen already is the Maxi other UIDs, so that you can set a policy that only the user can see in top, for example, only the processes that user has started, not the other ones that are also running on the system.
Yep.
So yeah, check out the Mac framework and maybe that extra module we've presented here.
Yeah, so there's quite a number of existing ones, and we'd love to see more documentation on actually using them.
Yeah, with use cases and what people are using it for. Maybe you have a little user story for us, then send it to us at feedback@bsdnow.tv.
So our next story is about the ping program. Tell us about that.
Yeah, so the ping program is a very old program, as you might have imagined. It's been, let me get the name right, Mike Moose, like the animal. And the homepage says, yes, it's true. I'm the author of Ping for Unix. Ping is a little 1,000-line hack that I wrote in an evening, which practically everyone seems to know about. And goes on. I named it after the sound that a sonar makes, inspired by the whole principle of echolocation. And in college, he pretty much did modeling of sonar and radar systems. So the cyberspace analogy seemed very apt. And it's exactly the same paradigm applied to a new problem domain. Ping uses timed IP, ICMP echo request and echo reply packets to probe the distance to the target machine. And he also writes that the original impetus for writing ping for a 4.2a BSD Unix came from an offhand remark in July 1983 by Dr. Dave Mills while he were attending with him a DARPA meeting in Norway, in which he described some of the work that he has done in his Fuzzball LSI-11 system to measure path latency using timed ICMP echo requests.
Yeah.
And then, there's a couple of more stories there. There's some strange behavior noticed in December of 1983. Recalling Dr. Mill's comments, he quickly coded up the ping program, which evolved around opening an ICMP-style socket raw AF-INET Berkeley-style socket, and the code compiled just fine, but it didn't work. There was no kernel support for raw ICMP sockets yet. And it also goes on to say, incensed, I coded up the kernel support and had everything working well before sunrise. Not surprisingly, Chuck Kennedy, aka Kermit, had found and fixed the network hardware before I was able to launch my very first ping packet, but I've used it a few times since then. If I'd known that it would be the most famous accomplishment in my life, I might have worked on it another day or two and added some more options.
Yes. He also mentions how he's insanely jealous of the person who invented traceroute by realizing that ICMP time to live exceeded messages by modulating the TTL field. And he's like, I wish I had thought of that. The other interesting one was debunking the whole backronym thing. So some people have, even in college, they tried to teach me that ping stood for Packet Internet Groper. And he's like, no, it's named after the sonar sound, and it's not an acronym.
Yeah, and I guess sonar sounds and ping are pretty much now in the main line that people understand what people mean by that. And there's a nice use case for that. He also has on his webpage. So it says the best ping story I've ever heard was told to me at a Unix conference where a network administrator with an intermittent Ethernet had linked the ping program to his VO coder program. In essence, writing ping, a host, then piping the set command for the ping, then that into the VO coder. And by that, he wired the VO coder's output into his office stereo and turned up the volume as loud as he could stand. And the computer sat there shouting, ping, 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 once a second, and he wandered through the building, wiggling Ethernet adapters and connectors until the sound stopped. And that's how he found the intermittent failure.
Yep. So ping on FreeBSD has this feature. If you use ping -A, it will emit a bell whenever a packet is received, or A will emit a bell anytime a packet is dropped.
Right, yeah, in case it doesn't reach any computers.
So you can do either way. You can make it, depending what I'm doing, I'll make it ping at me once the internet comes back up, or ping at me when it goes down. So if I'm going to go move some cables, it's like, okay, and I unplug the cable, and I hear ding, ding, ding. I say, okay, I unplugged the right cable, and then finish things up and get it plugged back in. Then when the noise goes away, I know that I've hooked it back up correctly.
Yeah, and ping is like, I use it almost every day. It's like, oh, is the machine up again? Like after I reboot it or something, it's like, just ping it and see whether it replies something. And it's so much part of the muscle memory now that you don't even think about all the options. But they have a couple of nice options. So check out the Pingman page for more things you can do with the ping program.
And lastly, we have a little story here from the sheeplog. So if you've been using PKG on an older version of FreeBSD, like 10.2 or something that's not supported anymore, you'll notice that the default branch that package provides is different now. So the way packages are built at FreeBSD is that the FreeBSD 11 branch the FreeBSD 10 branch packages are built on the oldest supported version of FreeBSD on that branch. So when 10.1 and 10.2 went end of life in January, we changed from building the packages for 10.1, 10.2, and 10.3 on 10.1 to building them on 10.3, because that's the oldest supported version now. So that meant we could start taking advantage of newer features like the capsicumized version of the UTime NS option, which gives you the modified time in nanoseconds or whatever. But if you try to run the newer version of package compiled for 10.3 on 10.2, which is what the repo provides by default, it will blow up in your face. So if for some reason you are doing some archaeology or something and need to run FreeBSD 10.1 or 10.2, then what you can do, it turns out, is in your package.conf, you can change the default location where it pulls up the packages. So instead of using the ABI/latest or /quarterly, you can use release underscore and then the number from the end of your version. So release underscore 0 is for 10.0, underscore 2 is for 10.2, etc. And there are a copy of the packages from the time the release was made. So realize that these packages are not updated. They are very old. 10.2 came out a very long time ago. So, it's not going to be like it's the brand new packages still compiled for 10.2. It's not a supported branch anymore. We don't build the things, but it could be enough to get the couple things working you need to do your experiment in a VM before you get rid of the 10.2 system, because you really should be running 10.3.
Yeah, upgrade at one point. But if you need packages in the meantime, then there's a way to solve that problem.
Or if you need to get things working again so that you can then upgrade, there is a repo out there that you can use. Of course, it provides package version 1.5, where the rest of us are using, 1.10. So just be warned that it's very old, but there are pin packages if you want to stay on the same packages for the entire life of the branch, a la the old way we did it in FreeBSD 7.
Yeah, so check out the blog post. There are examples there, and you can see what kind of changes you need to make to still stay at that very old version if you so desire.
So with the BSD bits this week, we got a bunch of quick links to walk you through. The first one is how to do temperature collection with collectd on NetBSD. So it says package sources version of collectd does not support the thermal plugin. So in order to publish thermal information, you need to use the exec plugin. And then he's written a little script that actually extracts the temperature. And then he uses some awk to get the stuff out of the envstat and puts the values into collectd. And now you're monitoring the CPU temperature from all of the NetBSD machines. And then they're using InfluxDB as the server. So sending those with collectd and then displaying them with Grafana. And you can see a nice little graph of CPU temperature.
Of a machine called Coruscant for the Star Wars fans. But yeah, in any case, however you name your machine, there's a way. If you have that kind of setup, then now you can use collectd to collect your NetBSD temperatures.
Cool.
And yeah, nice thing. And the next story is about the new Ryzen CPU from AMD. So we got a FreeBSD 11 booting with NVMe and ZFS on AMD Ryzen.
Yep, this is an article,
link here.
Article over at Serve the Home, which is a very interesting website with lots of building little servers for home type stuff. If you ever want to know about switches and NAS builds and all that kind of stuff, they have a lot of good articles and that kind of stuff. Whether it's, picking the cheapest 10 gig NIC for your house, or picking the switches, or anything you want to do with having a home server, it's definitely a good website to check out, and they have a great forum of other people that are doing things like that.
And so they ran that on their test system here.
Yep.
And seems like
apparently have also run the Knights Landing Xeon Phi X200 systems on FreeBSD as well. So they have a link to another article there that I didn't spot earlier when we put this in the show notes. But they have their basically showing how they got FreeBSD 11 running, booting off NVMe. So that's using UEFI and ZFS, and it all works out of the box without needing to do anything.
Nice. So if you are pondering getting one of those CPUs, although they're still expensive, I guess,
or sold out
in a lot
of places.
Yeah, especially with the NVMe setup. But if you're pondering that in the future, then you know that FreeBSD will run on it. Yep. The next story is a BeagleBone, what's it called? A Tor BSD site or a setup?
So there's
Tor relay?
Yeah, doing a Tor relay on a BeagleBone. So it's all the instructions you need in order to run, looks like OpenBSD on your BeagleBone Black and turn it into a Tor relay.
Oh, interesting for those people who are privacy sensitive or don't want everyone to see their traffic
in this
going.
particular one, a relay allows you to proxy other people's traffic in the middle, but you're not an endpoint. So it's not your address that people leave the Tor network. You're just one of the middle nodes where people bounce off of. It doesn't have the same level of,
exposure.
Yeah,
or
not the same exposure of being a Tor exit node, but you're helping the Tor network by being a relay.
Build the network,
and
provide the back infrastructure.
It's part of the NiceBugs project to try to get Tor to not be so Linux specific and try to have more of it running various BSDs so that they can, that one Linux exploit doesn't allow someone to take over all of the Tor network.
Yeah, which is a good thing. So people can try that out on their favorite BSD and run it on their BeagleBone.
Yep. So here we have an interesting commit by John Baldwin over at FreeBSD, which disables the in-tree GDB debugger by default on x86, MIPS, and PowerPC, saying GDB imports contains all the functionality that was in GDB and base, including KGDB, for these platforms, along with additional functionality. The in-tree GDB remains enabled on ARM and SPARC64 because there aren't replacements for that yet. Because the GDB imports does not currently support kernel debugging on ARM, and the port of GDB for SPARC64 has not been tested, though there is support. It's just not clear it's been tested. But the idea is that getting this old unmaintained code out of the tree and replacing it with a port that you can install that has a newer version with better features. And also, since in base we have LLDB now, you don't need GDB anymore. But it's still there in ports if you want it. Excuse me.
So check out the new LLDB and try it out on those architectures.
The newer features in the old GDB.
Okay, then the next bit is a meetup from the Charmbug, which is the Baltimore area BSD user group. And they are meeting at is it that location? Yeah, it's a Green Turtle.
Yep,
it's like a restaurant, I guess.
Yep, they're meeting at the Green Turtle. It'll be Thursday, April 27th. Our producer, JT, is one of the developers that's going. And I know Michael Shirk is also the organizer and host. Hopefully quite a number of BSD people out from the Maryland and so area will come out and meet up.
Okay, which is always good to exchange ideas and what people are doing with BSD that are in the area. So if you are in that area, go to that one and look for the design and implementation book on one of the tables. Then you found your group.
Something like that, yes. And then the last story we have is an interesting one that came up from the FreeBSD mailing list the other day, which is the origin of XXX. So if you've ever looked through code, you'll often see little notes in the comments, something like, XXX, this is a terrible hack and should be replaced, and things like that. Some other people will use fix me instead of XXX as the marker, and it makes sense. But this article tries to dig through the history and figure out where it came from. And you see, for this example, this is a temporary reference for this character or that character. And then there are other stuff where it's just, at one point it seems that in the 80s it was used just to mark which lines were changed back before source control when diffs were much more complicated. But then you just see some other ones like, saying XXX fix me. I don't quite understand what's going on here.
You might want to revisit this later.
Yeah.
Just in case.
But what's interesting is it also goes through looking at it and finding that it turns out XXX is a really bad string to use for that kind of thing because it shows up in a lot of other comments and documentation in ways that don't mean that. Like in this example, it's meant to denote a number of degrees, right? It's like xxx.xx will be a number of degrees as in like radians and so on to say, the code they're looking at here is some kind of NASA lander equipment or something. And there's another one here where it's used to just denote any string that comes after. You know, we use XXX to specify any 3 characters or whatever. And so it turns out that it's actually a really bad symbol to use for this. And so you should probably use fix me. But it does some interesting archaeology to try to figure out where this first came from. And it seems that the first XXX commit was actually November 9th, 1981, because it's definitely a fix me type thing, but it doesn't say why, and so on. And then they actually got a little confused with one they found. There were no instances of the XXX thing in Unix v2 through v7, but then they thought they found one in v1. But it turns out it was actually added in 2008 when somebody changed some of the v1 code to make it actually compile.
So that doesn't count.
So that doesn't
history.
count. Yes. But yeah, then there's some other examples here in 1981 where someone just used like a lot of X's.
Yeah, a little bit too much. But he will find that place in the code again if he looks for that specific thing. But
yeah,
if people are just looking for 3x, then yeah, not so much.
Yeah, but anyway, it's definitely interesting to see the history of where this thing came from. But before we get to the feedback on this episode of BSD Now is brought to you by Tarsnap. Go to tarsnap.com/BSDNow and check them out. It's backups for the truly paranoid. All your data is deduplicated, compressed, and then encrypted and signed on your computer using the key that only you have, and then transmitted to the cloud where it is stored safely and replicated. But that's why the encryption is so important. Because it's stored redundantly and replicated, there's no way to be sure that you can delete that data off every one of those machines because it uses the cloud. But because you have it encrypted with a key only you have, if you destroy that key, then you know for a fact that that data can never be retrieved. Yeah,
and Tarsnap is built on 4 basic design principles: security, flexibility, efficiency, and utility. So it's not just it's a secure solution, no one can figure out how to use it. It's also flexible, it's also efficient, and of course security is still the main focus why this was developed and is running currently for many happy customers.
If you can create a tarball, you can create your backups with Tarsnap. So, why don't you have backups yet? We've been trying to tell you about this for a couple of years now. Just sign up, give them $5 and try it.
Even though it's in the cloud, it's still secure, and you're the only person who has the keys to it. No one can get to your data, even though
all
it's
my important files, all the business stuff, contracts, my personal taxes, corporate taxes, all that, encrypted, sent to Tarsnap, because I really can't have those files go away.
Right. And it also gives you a nice way of paying for that. Like the pricing is 250 pico dollars per storage. So it's actually an interesting way of not just providing the service, but you don't also have to pay that much for it, even though if you're uploading gigabytes of data to it.
Yep. The gigabytes are only 25 cents, basically.
Yeah, very cheap. And you can get started with a couple of files and folders and check it out and see how it works for you, and then over time you can add more to it.
Yep. So on to the feedback.
Yes, there is so we got a lot of feedback, and we're still working through it, and this is just again an extract of those. And if your question hasn't been covered on the show, stay tuned, we still have a couple of more to cover. But the first one goes, hey there, nerds. Which is a nice greeting, by the way. I hear you're starving from feedback deficit. Yeah, a little bit. Not anymore, but yeah, we're getting there. Well, here I am. Ta-da! While playing with my home lab server and ZFS on Linux, I noticed that my L2 ARC was flushed, invalidated. After reboot, zpool iostat-v set 0
allocation.
I think bytes allocated, yes. Well, a few hundred megabytes actually, but none of those tons of gigabytes from prior to rebooting were mentioned. That's a rather surprising behavior. That means that the boot time of the bare metal host as well as the auto start VMs will not benefit from the L2 ARC on the SSD. What's worse, though, is that repopulating the L2 ARC burns through the SSD's write cycles much more quickly than reusing previously cached data. Maybe I did something wrong, forgot to toggle a persistent flag or something. I just opened a new search results tab for persistent L2 ARC reboot in this browser, and I'll iterate a promising looking list later. Maybe you can shine some light on wisdom that you might have on the topic, so young players like me can be aware of those traps. Why would ZFS do that? What monsters lurk in the roadside bushes on the path to persistence?
Right. So that is how ZFS works right now. There is no persistence. When you reboot, the L2 ARC is empty. The problem with an approach like, all right, let's try to... So the way the L2 ARC works is in the ARC, which is in memory, there has to be a pointer saying, this block is in cache. It's just over here on the SSD. So when you reboot, obviously those are gone. Now, with the way the L2 ARCs on disk format was written, there isn't really a way to reclaim those. It's designed for file servers that are up all the time, basically, right? The whole point of ZFS is high availability. But the other problem is, even if it was there, trying to reload the entire L2 ARC, where you might have terabytes of it, blocking you booting would probably make you angry more of the time than the fact that, your L2 ARC starts being cold. You don't want to have
a lot of I/O will happen during that time.
You don't want to make booting take 10 minutes longer or more because you're trying to load this L2 ARC in order to make booting your VMs a couple of seconds faster. Sasha Kiselkov from Nexenta has the start of a patch for persistent L2 ARC. And basically this will changes the on-disk format in the L2 ARC such a way that it could be reloaded. And then during boot, in the background, the L2 ARC starts reloading. So it starts adding those references into RAM saying, hey, data's over here on the SSD. Now, during startup, that's not going to help you that much. In the first 10 or 20 minutes, it'll make a difference. It'll mean you get to your high cache hit ratio sooner, but right when you're cold booting, it's not going to help you. It's not going to make booting the computer faster because you have to load all these pointers first.
But it's better than starting from totally zero.
And the other point you bring up is it will reduce writes on the SSDs because you'll be like, oh, that data's already there. I don't have to write it again. Although the other thing is we have to keep track of, we don't want to have old data in the L2 ARC, right? We don't want data that's been invalidated to still be there necessarily. Luckily, because of the way ZFS works, each different version is going to have a different object ID, and so we're not going to have to worry about cache invalidation quite the same way. But anyway, so this, as we talked about with Kris, this feature is on the way, but it might be the end of the year before it gets here. But persistent L2 ARC is being worked on because we realize that is something people want. It was actually one that came up interesting for me not that long ago, talking to somebody, and I found out they were mirroring their L2 ARC. I was like, that doesn't make sense. I understand mirroring your S-log because you want to have high availability on that because it's where your database is doing its writes until they can be buffered out to disk. But your L2 ARC, you'd be better off striping it together and having twice as much. But they're like, no, because if the SSD fails, we depend on the L2 ARC speed performance increase. Otherwise, our application is too slow and won't run. So having mirroring on the L2 ARC means, A, the reads are faster because you can read from either SSD instead of just one. And if one fails, we don't lose all of our L2 ARC performance. So I didn't realize that many people were quite as dependent on the L2 ARC as they are. So yes, persistent L2 ARC is coming, and hopefully it will be able to help you a bit there. But when the VMs are all booting right as the host machine comes up, it's probably not going to help that much.
Okay.
Yep.
Yeah, so we hope that answers your question, and you now have a clearer understanding what the changes are that are coming in the future for the L2 ARC being persistent. The next question is from Gabe. He writes, "Hello, Alan and Benedict. Through the recommendation of a friend, I began researching FreeBSD in 2012 as a secure and stable platform to host backend functions for my IT services company. Have been a sporadic viewer since episode 7 when I stumbled upon BSD Now while searching YouTube for FreeBSD tutorials. The show has been a huge validator for me professionally. Hearing from like-minded people who have found enterprise-grade solutions within BSD expressly serves to reaffirm certain truths in a computing world which is increasingly becoming obfuscated by profiteers and extreme capitalists. Thanks to BSD Now, I'm constantly finding new ways to utilize BSD in operations for my clientele and myself, freeing us from the unreliable, disingenuous proprietary software. The insights, commentary, as well as interaction offered in the RSC channel have been proven valuable." So yeah, thanks for that. With that being said, as of now, I'm still shackled to proprietary closed-source solutions for many of my day-to-day functions. My goal is to have FreeBSD 11 with an array of jails running Nginx, MySQL, PHP, Postfix, and some other software, and required dependencies so I may install Request Tracker, OpenCard, and develop a database for asset tracking based on a vision, which I have drafted and attached. This suite will reduce my reliance on third-party offerings and increase the portability of the data my business relies on. In order to facilitate that goal, I have begun writing installation and configuration scripts for each segment. My logic behind this is that if the scripts generate proper functioning servers, then the method I'm employing to deploy them is sound. Additionally, I foresee potential for the implementation of prompts so that as to enable configuration customization, increasing the versatility of the scripts. So far, I've managed to put together a portion of my web server installation script, and which is attached. So the questions for BSD Now are, first, is my logic sound regarding the creation of shell scripts to deploy these servers, rather than just trying to muddle through the whole installation willy-nilly?
So to answer that one, shell scripts are okay, but something that's a little more, what's the word? Not omnipotent, but when you can do it multiple times and it doesn't break it.
Yeah, it is omnipotent. No, it's idempotent.
Idempotent, yes.
Idempotent.
Yeah. So what you want there is where the script can be run a second time and it will ensure that everything is right and not do something that won't work if you run it a second time.
Yeah, right.
So instead of a shell script, something like an Ansible playbook or Puppet or something, although the advantage with the shell script is that it doesn't depend on the framework as much. But yeah, the typical problem with shell scripts is they're assumed that you start empty and run once and they can't deal with anything being out of place.
Right. And you can also run these usually on multiple machines in parallel. So with a shell script, you might need to have a parallel SSH session running, which is kind of, it works, but these frameworks like Puppet and Ansible are built that way and know how to distribute the workload to those other machines. If you're running and deploying a lot of machines in parallel, then you might want to look at those. Next question in that one is, what would be how should I segment these jails? So in case...
like in general, you have your Nginx, and then it's going to talk to some PHP FVMs that are going to talk to some MySQLs. You can put all those in one jail or have them in 3 separate jails. It just depends how you want to set up your network. In particular, though, Nginx and the PHP FVM might need access to the same files, your document root for your website. And the document root for the website might also, need access for third-party people and might need to be able, SFTP in to update the files. And then, the JPEGs will be served by Nginx and the PHP files will run through PHP FVM. So it's mostly up to you if you want to do that in one jail or 3 separate jails. Just be careful of the fact that, you need those files to be in sync across all of them. So you're probably talking about a nullfs mount or something.
Yep. Keep it simple.
And then Postfix and Dovecot, they need to share access to your mail directories, right? Well, actually, no. Only Dovecot needs it because it does... Postfix will call Dovecot to deliver new mail, and then Dovecot will provide your IMAP server to allow you to pick up the mail. So yeah, Postfix needs to be able to actually fork and exec Dovecot. So you can probably put those both in the same jail, although you put them in separate ones and have Dovecot be in both, and delivery would come via Dovecot to the nullfs mount in the Postfix jail, and then the IMAP server would run on the other one, but then you're just running Dovecot twice for no reason. And then, so it's up to you. For my setup, I have a mail server jail that's Postfix, Dovecot, and Request Tracker. And then But each of my MySQL servers is its own separate jail. So it depends how you want to set it up. There's not necessarily I'm sure there are lots of wrong ways of doing it, but any of the reasonable ones are pretty straightforward.
Yeah, you can do a whiteboard exercise or write it on a piece of paper and draw connections between them, and soon you see how many things overlap and how much different.
Because there's also the question: your PHP FPMs, when they're going to connect to MySQL, do you want to use a TCP connection to that? Then it's easy to have it in a separate jail. But if you want to do a Unix domain socket, then they should be in the same jail.
Yeah, all these things.
The other thing is, if you're going to use the resource limiting that FreeBSD has, RCTL, sometimes you can do that per jail, and sometimes you want to limit Nginx, PHP, and FPM as one thing rather than limiting each of the three normally, right? It's like all three of these can have a gigabyte of RAM they can share rather than, say, giving 333 megabytes to each of the three, and it turns out Nginx isn't using all of it, and MySQL could use that for more cache. So there are sometimes advantages to bundling a couple of the things together. But the nice thing I like about having separate jails is that it means later when I'm like, oh, this machine's too busy now, I have a second machine, I'll move the SQL database and the mail server to that one and leave Nginx and PHP FPM on the first one.
Yeah, you're still flexible in that regard. Yeah. So further questions he has, what would the appropriate order of operations be for these scripts? So his suggestion is first to set up the FreeBSD host, second to update the FreeBSD host as well, then harden the security on the FreeBSD host, fourth, build and configure the jails, and fifth, build and configure services within jails, and sixth or more, verify the functionality, backup data, restore data, update host and jails, reconfigure, etc.
Yep.
So what's the... Yeah.
That sounds about right to me, Most of the auto deployment stuff for FreeBSD we have, first thing it does on boot is run FreeBSD update before it even enables the immediately after it enables the network, but before it starts the services, so that, if there were, say, a bug in SSH or something, it would get the updated version before SSH starts on the first boot. And then, the way we do it where I work is you get to install FreeBSD, it gets updated, then you do the package bootstrap in order to get package, and then we install Puppet, and then Puppet configures the rest of the system and builds the jails, and then configures the services in the jails and goes from there.
Yeah, you want to have a minimum working version and then pull or distribute the rest from a control machine onto those hosts. What's the current best tool to deploy and manage jails for my use case? Is it EasyJail, or should I look into IOCage, Warden, or something else?
So Warden is going away, so I wouldn't look at that one. The best two that I know of are EasyJail and IOCage. They take different approaches. That one's really up to you. I still use EasyJail, but IOCage is looking pretty interesting. In particular,
I've been dabbled with...
I'm not... when I started using EasyJail, I had small enough hard drives where it actually was advantageous to have the nullfs jail thing and basically have one install of FreeBSD that all my jails shared and being able to upgrade them all at once. Now I have a lot more jails on a lot more machines, and I have lots more space, and I'd be happy to have a separate FreeBSD install, a fuller one, for each jail, even though that would waste a couple of gigs of space, because I could update them independently and update them using the standard tools instead of having to, EasyJail updating the etc files is a bit more work, although there are instructions how to do it in the handbook now, because one too many people suffered through that and wrote it down.
Yeah.
Thank you,
I've been
Warren.
using IOCage for 2 new jails at work, so just to see how it works, and also one is just using a test installation. The other one is a little more productive, meaning that the students are working on that without them knowing. And the only thing, it's nice and easy to manage and set up, but the only thing that I found weird that apparently it uses only 1 CPU of my 8 CPUs that I have. So I've tried to figure out what the problem is there. Yeah, so
what thing only uses 1 CPU?
The IOCage. So I ran so I do some custom builds of ports because they have some options that I need, and I compile it, and from the CPU graph, I only see that 1 CPU is running, and the other 7 are just
So this
idle.
is for compiling ports? using IOCage?
General, any load that I put on the IOCage jail is run on only one CPU. But that's
I know there's the ability to
question.
limit the CPU set, because I often have certain jails have access to all but one CPU, so that if it uses up all the CPU, there's still one CPU that it's not using up.
Yeah. I looked at that and I didn't pin it to a specific CPU, so I might need to get back to or file a bug report maybe.
Possibly.
So that shouldn't, put you away from using IOCage or having a look at it. Dan Langell has a nice updated or relatively up-to-date tutorial on his website on the BSD diary, so you can check that. Or if you just Google, you should be able to find enough tutorials for that one.
So Gabe asked if he's using the wrong tools. Possibly, something like Puppet or Ansible probably makes more sense. But
over the long term, yeah.
But who doesn't like a good old-fashioned shell script?
Yeah, it's. I mean, it's there. It works directly on the system without installing extra software. And yeah, if it works for you, and if it's just a 5-line shell script, why write a big playbook in Ansible about it?
But I'm pretty sure what he's got is going to be a rather large shell script if it's going to set up all of those things. Puppet and so on usually just provide slightly better things for things like, and change this one line of the config file. Although oftentimes they're just using the same thing a shell script would, which is like, set in awk.
Yeah. Or just like this certain configuration file needs a comma as a separator, that other configuration file needs a semicolon, the other one a space, and all these tools know how to integrate with these configuration files, and they can make sure that if you add multiple lines to that one, it will be properly separated.
Yeah.
And that needs to be coded into your shell script rather than being part of the, infrastructure.
A lot of the abstraction's already been done for you in these tools, so why do it again?
Yeah. The last question is this whole thing over-engineered? Well, you just have to try it out and see how complex it's going to get.
So he has an example of his script here where he's installing Nano, Nginx, MySQL Server, PHP, MySQL-i, a couple other modules. Then he copies the config file, uses sed to replace some things. Then uses sysrc, at least he's using sysrc to enable the services, start the services, change some lines in his nginx.conf and PHP FVM and so on. And starting the services. That's not bad.
So from that, you can use that shell script and then, try to start developing either Puppet or Ansible or any other like Chef or whatever solution you might want to use. And, slowly but steadily use that as a template to move into one of those solutions and see how that works.
Yeah, so
then you can immediately see what kind of benefits that gives you.
Yeah, like the biggest difference, I'd say, is if you did this as a Puppet one or whatever, is you can say ensure latest on package PHP 7, and it will basically automatically update it if there's a newer version. Although you can say just ensure it's installed instead if you don't want it to auto-update stuff for you. But it can do other things like automatically detect when you change the config file for Nginx and run service Nginx reload. It can also check that if you say that Nginx should be running, it will check, and if Nginx isn't running, it'll start it. And if, in Puppet, it runs every half hour by default. So if for whatever reason Nginx gets stopped, it'll start it again. Whereas your shell script won't necessarily do that. Like the
triggering of certain events.
Yeah.
That's been done.
But in general, it looks okay. So next up, we have a question from
keep
Scott.
Us updated. So Scott writes in his post to us, it's about FreeNAS and lag. He says, "Hello BSD Now crew, I'm using the new FreeNAS Coral setup." Oh, here we go. "And loving the new interface. I'm setting up a FreeNAS server for our development company, and I'm interested in using link aggregation. We use a lot of large Photoshop files, and I think it would be worthwhile setting up a lag interface. I have a Dell PowerEdge R7010 with 4 gigabit NICs. I want to know what protocol I should use. FreeNAS offers the following. It's Ether channel, failover, won't need, LACP, load balance, none. What does none mean? Round robin. So those 1, 2, 3, 4. Ether channel, LACP, load balance, and round robin. Which protocol should I use if we are going to mount a SMB share for our staff, which they will constantly read and write from? And is there anything I need to worry about when it comes to setting on our switch? E.g., some Googling tells me that LACP requires support on your switch. Many thanks for the awesome show.
Okay.
Yeah.
So the first thing to realize is that the limitation of lag is that any one TCP connection is only going to use one member of the lag. So if you don't have at least 4 different computers connecting to your NAS, then having a 4 gigabit lag isn't going to help so much. So by default, most switches can only, the cheaper switches can only support lags based on MAC address. Whereas fancier ones, you can often configure to do it a hash based on like the IP address and the port number. So if it's just the MAC address, you need at least 4 separate MAC addresses to be able to use all 4 NICs on the lag. And because it's a hash, it means that, you know, if you have 6 different machines connecting to your NAS via the 4 NIC lag, there's a good chance that, you know, 3 of those 6 machines might try to use the same NIC. Whereas the load balance mode will try a little harder to do that. In general, almost all these modes are going to need help from the switch. With a dumb switch, the problem I had was even if I configured, say, a load balancer, which is, I think, basically the same as Ether channel, my FreeBSD machine would try to send the data over multiple NICs to the switch, but the switch would be like, all of this traffic is going to this one MAC address, so I'm going to send it out the one port I know that machine is on. And so FreeBSD ends up throttling itself back on because TCP and sending 500 megabits out of each of the 2 ports because that's the fastest the other machine can receive, even if it's also plugged into the switch with 2. And your switch can get very confused when it sees the same MAC address available on 2 ports, and it'll try to like bounce back and forth and cause problems. So yeah, really what you want is a switch that supports LACP, which is basically just a protocol where the switch can automatically adjust the lag group based on which NICs are actually up. But that's the best way for the switch to know when your one computer is connected by 2 or more ports instead of just 1. And then in your cheaper switches that don't have much management interface, most of the time the LACP hash is just the MAC address, meaning that if you don't have multiple physical machines, or at least, VMs with different MAC addresses, then the traffic's only going to use one member of the lag.
Right.
Whereas if you have lots of separate machines, then sure, you'll be able to use the lag and balance the traffic. But
it's also a question of whether you need it for, or do you want to have it for performance reasons or for failover reasons?
Yes, with failover, that's just in case a NIC or a switch dies. Often what you'll have is multiple NICs that go into different switches that are then linked together, and so that if one of the switches dies, your network stays up. But you said in your notes here you don't need that. So yeah, the difference between so with load balance mode, FreeBSD will, for each network connection, it'll just do whichever NIC is the least busy right now is the one that'll get the load. With round robin, this violates the Ethernet standard by literally sending each packet or each Ethernet frame out the next NIC. So you've got a bunch of frames going, it just goes 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and just sends the data as fast as possible. But your big problem there is that the switch on the other side might try to put them back in the right order, which will eat up all the CPU time on the switch and actually make it even slower. Or, just hurt TCP a little bit. But in general, LACP is the... So if you're connecting server machines back to back, then FreeBSD to FreeBSD or FreeBSD to another machine, then load balance or round robin can work quite well. But when there's a switch involved, you pretty much need to use LACP. Although you can use load balance or Ether channel if you can create what's called a static lag on the NIC, on the switch. But again, the hashing on those is usually not very good. So I've had the best luck with LACP, and I've had to replace, $199 switches with $699 switches in order to have the hash be based on the IP address and port number instead of just the MAC address. From one of my examples at a data center, we had a switch where we had a 2-port lag to the ISP. So we had 2 gigabits out to the internet. But the ISP has one router, which has one MAC address. So my 4 machines, each with 2 ports into the switch, could balance their traffic all they wanted. But when the traffic got to the switch is like, well, I happen to know that this one MAC address you're trying to send across this lag to the ISP happens to fall on the left side of this lag. So all the traffic went out the one NIC and the second NIC did nothing. The ISP hashed the traffic properly with their, $20,000 switch. So incoming traffic was balanced between the 2 ports, but then my switch would always send it to just one port on the receiving machine as well. So I was never able to actually get, even with multiple connections, multiple gigabits. So I had to buy a more expensive switch that would let it hash properly, and then the traffic gets split quite well. But in the end, almost none of these is a good solution for, I need 2 gigabits between machine A and B, other than running the cables directly or something. But if you have a NAS that's shared between 6 workstations, then this a multi-NIC lag is likely to do pretty good for you. Or at least mean that you can do a gigabit to each of the machines rather than all of them sharing 1 gigabit.
Yeah, especially since he writes that there's this SMB share that the staff is constantly reading and writing from, and they're using these large Photoshop files.
Yeah.
So that might be
if each of them has their own machine or laptop or whatever, then yes, the multi-NIC lag will help.
Okay, so we hope that answers the question. And good luck with your server, and maybe you will become a full BSD Beast developer thanks to you or thanks to us. We'll see. And our last question is from Marco. Hi, the BSD Now team. Some time ago, I overheard a discussion about backups, which made me think, in particular, the verification part. When bits leaves the hard drive out of the computer through the wire to another computer to another hard drive, or tape, or whatever you have, flash drive maybe, what makes sure that bits left first computer are exactly the same as bits being written and verified being written, not just blindly written, on another computer? I'm asking about ZFS, of course.
Right. So ZFS has the checksums. So when you create the data, we also create a checksum with it, and those both get written to the disk. Then when we read the data back, we also read the checksum and make sure that that data is still the same using the checksum. Sometimes it's not. If your hard drive does something wrong, like accidentally write the data to the wrong spot on the disk, or bad SATA cable means that the data gets garbled as it goes to the disk, it won't match, and ZFS will detect that. ZFS replication for doing backups solves this as well, because it includes the checksum in the replicated data. So when it arrives on the other machine, it includes the checksum and it can check it. And the actual send stream has a checksum as well, so you can detect if it gets corrupted on the network as it's going across. However, if you are taking a backup rather than doing ZFS replication, it doesn't necessarily help. But software like Bacula does support checksums. It can actually take the SHA-256 of the file as it backs it up and store it in its catalog in Bacula, and then when it goes to restore it, it can check it against that.
So that answers the question about what to look out for when moving data around. Does CFS run verifications automatically? Yes, it does.
Yeah. So, or does the user have to do something? It turns out both. So ZFS verifies the data every time you read it. So every time it pulls it off, every time we pull it off the disk, it checks the checksum and makes sure it's right. However, with backups, oftentimes you write them and never read them, so then they wouldn't get checked, and maybe they get bit routed over time because of your hardware. So ZFS also has the scrub operation. So if you run zpool scrub and then the pool name, it will go through and read every single file and check its checksum. So this is a good thing you do once a month or once a quarter on your backups to make sure that all the data you backed up a long time ago is still exactly as it's supposed to be. Because if it's not, it can usually repair it using, if you have mirrors or RAID Z, it can repair the broken data if you detect it soon enough. If the bit rot keeps happening, then eventually maybe both copies, or the RAID and the parity, or the original and the parity data get corrupted, and then you can't restore it. So running ZFS checks it every time you read it, but there's also the scrub operation, which checks everything so you can deal with files you don't necessarily read. Yes. Does it verify on the fly that written data to other disks is the same as the read from the original disk? Yeah. So basically, when you generate the data, when your application asks ZFS to write it, it checksums it there and writes the data and the checksum to the disk. And then if you do replication, or if you read the data, it reads it, checks the checksum. If it's wrong, it will try to repair it. And if it can't, it returns an error instead of giving you the garbled data. So yeah, it's basically one of the things that makes ZFS mirrors safer than other RAID mirrors. If one of the hard drives goes bad in a regular hardware RAID mirror, you can't tell which of the two copies is good. You just know that they're different. Whereas in ZFS, because of the checksum, it knows which one's the good one and can copy the good data over top of the bad data and have both hard drives be right again. Whereas hardware RAID is like, I don't know which one's good. Maybe it guesses, or maybe it does nothing. Yeah.
Call customer support. Yeah. Mm-hmm. But at that point, yeah. You're doing good choices about thinking, using ZFS, but also thinking about, how the backups are being done and how the data is actually being, verified and what the particulars are about verifications in ZFS.
The most important part about taking a backup, step 1 is take backup. Step 2 is make sure that you can actually restore the backup and that the restored data is correct.
The same one you originally backed up.
Yeah. And that's where ZFS replication comes in nice, because you include the checksums, so there's no extra work, and every time you go to read it, you can verify the checksum. And you can do the scrub operation to verify the data every so often.
Yeah, like a cron job in the background every month.
Cool. Well, that's it for the questions for this week, but we'll have more questions next week. And if you have a question, make sure to send it in to feedback@bsdnow.tv, and maybe you'll be on the show.
Yeah, next week. And thanks for checking out this week's episode, and see you next week.